One of the ways that science can teach us more about the history and development of the various species of life on our planet is by uncovering and studying the fossilized remains that the ancestors of these life forms can sometimes leave behind. Over the years, the archaeologists and paleontologists who discover these fossils have made amazing discoveries that have changed the way we look at human history and the evolution of life on Earth. Of all the fossils known to science, however, perhaps some of the most intriguing and mystifying examples of fossilized life ever found are those present in a small rock known by the name of ALH84001. Named for the Allan Hills region of Antarctica in which the sample was recovered, microscopic analysis of the object revealed what appeared to be the fossilized remains of ancient bacteria. Such fossils of primitive life are rather common and would not have been especially interesting or unusual if it weren't for one important detail about the rock in which they were found. All available evidence pointed conclusively to the object having originated millions of miles from Earth, in the cold, red dirt of Mars. The meteorite known today as ALH84001 formed a little over 4 billion years ago when molten lava cooled on the surface of Mars, possibly following the eruption of an ancient Martian volcano. The near incomprehensible age of the object making it among the oldest existing in the entire solar system. Beginning its life in a region of the red planet known today as the Valles Marineris, also known as the Mariner Valley, an enormous canyon system that lies on the Martian equator, the igneous rockbed from which ALH84001 was birthed existed at a time when Mars was thought to have had an abundance of liquid water. Analysis of the sample seemed to provide further support for this theory by yielding evidence that it had once been part of an ancient aquifer, an underground layer of permeable rock that allows for the storage and movement of water below the planetary surface. Following over 4 billion years of existence within the aquifer several meters below the surface of Mars, ALH84001 was ejected from its homeworld when an interplanetary object collided with a red planet, blasting Martian debris into outer space and sending ALH84001 on a 17 million year journey through the inner solar system which, roughly 13,000 years ago, would see it come crashing down through Earth's atmosphere and landing in the Antarctic ice, where it would then sit laying in the cold, awaiting discovery. The Allan Hills meteorite was first uncovered by a group of American scientists working with the ANSMET research program, a group dedicated to hunting for meteorites in the Antarctic ice, on December 27, 1984. Antarctica provides a uniquely fruitful location to search for meteorites. In fact, Antarctic meteorites represent nearly 2/3 of all meteorites ever discovered on Earth. This is not only because the icy desert provides an excellent backdrop for such objects to stand out against the undisturbed snow, but also because of how ice flows across the continent. Over the centuries, as ice sheets shift, they carry with them any interplanetary debris that may have fallen upon them, just like a conveyor belt, until they encounter large obstacles such as the rugged mountains that exist below the frozen surface. In such locations, any debris that may have fallen onto the ice from space is left to accumulate near the barrier, allowing for predictable and relatively high-yielding sites from which researchers can then collect samples. At the time of its discovery, ALH84001 weighed just over 4 pounds and measured in at 6 inches long by 4 inches by 3 inches, a little bigger than your average can of soda. Following its retrieval from the icy fields of Allan Hills, ALH84001 was sent back to the NASA Johnson Space Center in the United States, where it would wait patiently for further study. When researchers first analyzed the meteorite nearly a decade later in 1993, it was confirmed that the composition of trace atmospheric gases trapped within the rock was a perfect match with the atmosphere of Mars, providing undoubtable evidence that the rock was in fact Martian in origin. Holding a piece of another planet in their hands must have been an exciting feeling for those studying the object at the time, but the real excitement was still yet to come. The peak of the flurry surrounding ALH84001 took place 3 years later, in 1996, when a team of NASA scientists led by researcher David McKay published a paper in the journal Science titled Search for Past Life on Mars, Possible Relic Biogenic Activity in Martian Meteorite ALH84001. In the paper, the authors brought attention to the presence of minerals and geological features within the Allen Hills meteorite they believed could best be explained by organic processes, suggesting that what they observed was in fact quite similar to effects known to be produced by bacterial life present on Earth. Where things really got exciting was when the researchers used electron microscopy to take a closer look at drops of an orange substance known as carbonate found within the sample. The observed carbonate was believed to have been formed when water rich with carbon dioxide, CO2, from the Martian atmosphere first penetrated ALH84001 in the distant past. Within these deposits, researchers were shocked to see features that shared a strong resemblance to earthly bacteria, raising the possibility that they had indeed found fossilized evidence of life native to a planet beyond our own. Having already ruled out possible sources of earthly contamination, researchers concluded that features observed within the rock were most likely the result of primitive life that had originated on Mars in the distant past. The discovery at the time seemed so monumental that news of what had been found quickly spread across the world, eventually leading then-President Bill Clinton to hold a press conference in which he remarked that if this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever discovered. Its implications are as far-reaching and awe-inspiring as can be imagined. But the case was not as open and shut as the researchers would have hoped, as there was in fact a problem with the alleged fossilized bacteria. It was several times smaller than any of the bacteria with which we're familiar here on Earth. In fact, if the structures within ALH84001 really are fossils of primitive life, such life would have been so small that it would not even been big enough to house the basic cellular structures necessary to life as we know it. It's been suggested that these fossils may be the remains of hypothesized nanobacteria, a theorized type of extremely tiny bacterial-like objects for which scientists have found evidence to support their existence, but of which we currently know very little, including whether or not they are in fact alive. No doubt expecting pushback against claims of such a tremendous discovery, the researchers were careful to point out in their work that the unusual features of ALH84001 could have been produced by certain inorganic processes, but that when all the evidence was taken together, it was their opinion that a fossilized signature of Martian life was in fact the most probable explanation for what had been observed. Given that the quest to prove or disprove the existence of alien life continues to this day, it should come as no surprise that in the years that followed the announcement of the discovery found within ALH84001, that doubts were raised as to whether what was observed in the sample was in fact biological. While the scientific community has found consensus in agreeing that the rock and its observed features did in fact form on Mars, the debate continues as to whether the presence of minerals in the rock were formed by alien microbes, or if perhaps then unknown geological processes could have been responsible. Scientists have since been able to show that minerals within the sample thought to be of biological origin could also have been produced under conditions of extreme heat and pressure, such as those that would have been present in the immediate aftermath of the cosmic impact that sent ALH84001 hurtling into space some 17 million years ago. So while the Allen Hills meteorite may have given us a tantalizing hint into the possibility of non-terrestrial life existing in what is essentially our own cosmic backyard, ultimately the burden of proof for such a fantastic claim is simply too high to be met by a single questionable sample. But while ALH84001 was unsuccessful in providing inarguable proof for the existence of alien life, where it did manage to make a significant impact was in helping to boost public interest in space exploration and in providing direction for future space programs that would aim to search for signs of life on other planets. As one of the foundational events responsible for shaping the field of study known today as astrobiology, which seeks to understand the conditions for life in the universe and how it may arise on planets beyond our own, the observations made of ALH84001 have forced scientists to reevaluate their preconceptions of what alien life might look like should we ever actually find it. It has also been suggested that ALH84001 may represent evidence in support of panspermia, the theory that life may spread itself through space by hitching a ride on interplanetary objects such as meteors. If this is true, the sample may even represent evidence that Earth could have been seeded with life by Mars, which is thought to have had even better conditions for the development of primitive life than Earth did many billions of years ago. The discovery, which Bill Clinton described as a vindication for the continued support of the American space program, would help to create the political will necessary to fund further research into studying the origins of life in our solar system. 1 year after the presidential address that followed initial reports of the discovery, the American Mars rover Sojourner would become the first to operate on a planet beyond Earth, and would mark the beginning of the robotic exploration of Mars in the quest to find evidence of past life. Today, this legacy is upheld by both the Curiosity and Perseverance rovers, which continue to search for biosignatures on the red planet to this very day. In the future, NASA has proposed a Mars sample return mission scheduled for 2026, which would aim to collect rocks and dirt from the Martian landscape and bring them back to Earth for further study. Such samples could provide the evidence needed to answer the many questions raised by the fascinating rock that fell to Earth 13,000 years ago. Until then, we're left only to wonder if the structures within ALH84001 are simply the result of natural geologic activity, or if in fact they're the proof we've been searching for all along that demonstrates the existence of life beyond Earth.